Okay, in this video, we're going to give you a crash course on simplifying algebraic expressions. So what does that mean? Well, here I have a big long algebraic expression, 5x plus 4x minus 10x over 5 plus 6. That's a lot of steps, and I'm not told what x equals, but I can do what's called combining like terms to simplify all of that down to just 7x plus 11. And this expression will give me the same value as the original expression, but it's much less steps or much fewer steps. We're going to look at why this works and how to do it. So real quick, just to review, remember we talked about what terms are. Here is an expression. That's the first term, the second term, and the third term. Here's a different expression. We have the first term and the second term of that expression. So we have a three-term expression and a two-term expression. Remember, the terms are broken apart by addition and subtraction. Multiplication and division don't divide the terms, only addition and subtraction do. We also talked about algebraic terms. Algebraic terms are terms that have variables in them. So, for example, the 3x, that's an algebraic term, and the plus 2y is also an algebraic term. On the other expression, we have the minus 11y over 5. Remember, even though there's multiplication and division there, that's all one term. That is also an algebraic term. Unlike the numbers here, the minus 2, that's called a constant term, and the 3 is also called a constant term because no matter what x and y are, they will always be minus 2 and 3. They're a constant. Now, the trick to simplifying expressions is doing what's called combining like terms. So let's talk about what like terms are. Like terms are exactly what they sound like. They're alike. So for example, in this first example, I have an algebraic m term, 3m, and I have an algebraic m term here in plus 2m, and I also have a constant term. Well, obviously the algebraic m terms are called like terms, and they can be combined through addition. On the other expression, I have an algebraic x term, and I have a plus 5 constant and a plus 2 constant, so the two like terms, constant terms there, could be combined. Combine our like terms. Now what this looks like is taking those 3m and plus 2m, and since I'm adding them together, they can become 5m. And then I just bring that minus 2 down because that's an unlike term, and then my expression has been simplified. On the other one, I have 3x, and then I'll just combine the plus 5 and the plus 2, and that makes plus 7 when I add them together, and then I'll bring down the 3x. So that expression has been simplified. Now just to show you why this works and what you're actually doing here, here I have 4x plus 3x, which is, those are two like terms. So if I show you, let's say these models represent 4x's, and I have 3x's. If I want to combine those into 4 and 3, I get a total of 7x's. And that's why simplifying works. They're the same type of term. They're like terms. Really what you're doing is you're combining your coefficients. So the first coefficient was 4, the second one was plus 3. That of course is 7, and that's how we simplify algebraic like terms. We just add or subtract their coefficients. Now to show you why this math actually works, let's just put in x is worth 4. So instead of x, I'm going to have all of these be worth 4. If I take my original expression and I do 4x plus 3x, you can see that when I sub in a 4 for both of those x's and do the math, order of operations, 4 times 4 is 16, 3 times 4 is 12. If I add those two together, 16 plus 12 is 28. So that's subbing in the 4 in my original expression. Now if I do the same thing in my simplified expression of 7x, if I just put an x in for that, or a 4 in for that x, and I do 7 times 4, that's 28 also. So simplifying expressions is making the expression less steps, but still having it be worth the same amount. In this case, it's worth 28 when x is 4. Now you also need to understand what's called unlike terms. Now here I have models for x and m, and I have the expression 2x plus 3m. And you might think that these are like terms because they're both algebraic terms. but actually the first term is an algebraic x term. There's two of the x's, and the other one is an algebraic m term, which are different numbers. So when I go to combine them, I can't say, okay, let me take two x's and three m's, and now I have 5xm, I guess. That's not true.
We don't do that here.
Thank you, Black Panther. You can't combine unlike terms, and here's why.
If you take this example, and again, I'll use x is 4, and we'll say m is worth 3. Now when I go to replace these values with 4 and 3, so 4's for the x's and 3's for the m's, you'll see that when I plug it into the original expression, a 4 for x and a 3 for m, I get 8 plus 9, and then when I add those together, I get 17. So the expression's worth 17 when I evaluate it for those values. Now the bottom one, if I said, hey, this is 5xm because I combine like terms, well, they're not really like terms. And when you see, when I sub in 4 and 3 there, if I do 5 times 4 times 3, that's 60, which is not the same thing. And so that's why
we don't do that here.
We can't combine unlike terms. Now, so again, to simplify an expression, all you're going to do is combine like terms. So for example, here I have a 4k plus 11k plus 8 plus 3. This is a lot of steps, so I'm going to simplify it down by combining my algebraic k term with my algebraic k term. Those are like, and I have a constant plus 8 and a constant plus 3. So those are like as well. We're going to combine like terms. So simply just add the coefficients 4 and 11 to get 15k since we're adding, and add the 8 and 3 since we're adding those both, and that's going to be plus 11.
Expression simplified.
15k plus 11 is the simplified version of this expression. Here's another example. It's a little bit trickier. I have algebraic h term, I have an algebraic a term, remember those are different, and then I have a minus 6a term, and I have a constant plus 3. So the only like terms in this expression are the two algebraic a terms, so I can actually combine those. When you do that, remember we have plus 8 and we have minus 6. So all together when we do 8 minus 6, their coefficients, that's 2a. And then I'll just simply bring down the 3 and the 6h. So the final expression is 6h plus 2a plus 3. That's the only simplifying I can do here.
Expression simplified.
Now a couple of other things that are important to understand real quick. Here I have 4x minus 3x. So remember you're combining your coefficients, and that's 4 minus 3. So that's going to just give me 1x. However, if you have 4 x's and you take away 3 of them and are left with 1x, we don't actually write it as 1x. We just write it as x. And you can see there in that picture that y1x is just called x. So when the coefficient is 1, we just don't write it. Okay? Also, 4x minus 4x, that is, of course, if you combine, it's worth 0, right? So 0 x's. In this case, if you have 4 x's and you take away 4 x's, you are left with nothing. And so we don't write 0x, we just write 0 in those cases. Which makes sense, because if you have anything and you take that thing away, you have nothing now. It doesn't matter what x is, the expression will always be worth 0. And lastly, one more thing to talk about, just like we can't combine like terms with addition. So for example, I can't say, hey, 8g plus 3 is 11g. No, that is not true because they are not like terms. And of course, we can show that by saying, well, if g is 2, then if I do 8 times 2, that's 16. And if I add 3 of that, I get 19. That's true. But if I take that 11g, which I wrongly simplified, and I do that times 2, that's 22. They're not the same thing. Okay? So that's why doing that doesn't work. But you can multiply it. So don't think that this is unlike terms, because remember, multiplication is not a split of terms. It's only addition and subtraction that produce different terms. So when I say 2x times 3, I can do that. And think about it. If you have 2x's and then you triple that, so now I've tripled it, Now I have 6x, and really all I've done is taken that coefficient and multiplied it times 3, right? 2 times 3 is 6, so this is 6x's.
Simplify.
So multiplying is possible. And don't think that that is an unlike term. It's not a term difference. You can multiply. Let's show why this works. So if, for example, x is 4 here, and I plug in 4 for 2 times 4 times 3, 2 times 4 is 8, and then 8 times 3 is 24. If I take the simplified expression, 6x, and I plug in a 4 there.
Well, that's going to equal 24 also, and that's why it works.
And, of course, since you can multiply, you can divide. So here I have 8x, and I'm going to divide that by 4. You can do that. So, for example, here are 8x's. If I divide that into 4 groups, I'll get that each group is worth 2x's.
So really, all I did was divide the coefficient by 4, which you're allowed to do.
Okay.
Expression simplified.
And again, just to prove that that's correct, if I take x equals 4 and I say, okay, let me plug it in, and I'll do 8 times 4 over 4, and then 8 times 4 is 32, and then if I divide that by 4, I'll get 8. Where if I took my simplified expression, 2x, and then I plugged in 4, I will also get 8 when I do 2 times 4. So that is really everything you need to know. So try some practice problems, see if you can figure out how to simplify expressions.